Alright, so this is question number 9, and in this question we'll use certain concepts and equations that we had derived from the basic nuanced equation to calculate the required quantities. So basically the question that we have to solve here is calculate the equilibrium constant for the following reaction at 298 Kelvin, and the given reaction is Sn plus 2Cu2 plus gives 2Cu plus Sn2 plus, and the corresponding half reactions are also given along with their corresponding E0 in volt. So Tushar, please take us through this question.
Okay, we need to calculate equilibrium constant for the given reaction.
Right.
So as I told you in the beginning, we write Nernst equation as E cell is equals to E naught minus 0.0591 by n log Q.
Right. So this is the basic Nernst equation, which you should be familiar with right now. Should have it memorized.
So at equilibrium, Q is equals to K equilibrium, that is reaction coefficient or quiescent ratio is equals to K equilibrium.
Yeah. This is the equilibrium condition, yeah.
And E cell is equals to 0 as delta G at equilibrium is 0 and delta G is equals to minus NFE. So hence if G is 0, E would be 0.
Yeah, so this is basically the conditions at equilibrium. So we'll move on.
Hence we can write E naught as 0.0591 by n log K equilibrium.
Right.
This is the formula I told you in the beginning, and this is a small derivation for the formula. It's not exactly derivation, it's just a conceptual thing if you see it very carefully.
Yeah, as long as you know the equilibrium conditions, you should be able to derive this very easily.
Okay, so if E naught is known, we can easily calculate the value of K equilibrium.
Right.
So we'll focus our attention in calculating the value of E naught.
Alright.
So the half cells reactions are given in the question, for which E values are given.
Right.
So we'll write the half cell reaction, that is Sn gives Sn2 plus 2 electrons and
Right.
2Cu2 plus 2 electrons gives Cu plus.
Right.
The value of E naught is given here.
I think it will be 2Cu plus there, right? Below.
Oh yes.
Yeah.
So here it would be 2Cu plus.
Yeah.
Now from this we can write the net reaction, but here that is not important. The important part here is to calculate the value of E naught.
Yeah.
So E naught is given here as this. So for Sn to be oxidized to Sn2 plus, the value of E would be reversed.
Yeah, it will be minus of minus 0.14 because the reaction is reversed.
And for the other, that is Cu plus electron gives Cu2 plus electron gives Cu plus, the value is 0.15.
Yeah.
Hence we can write the value of E naught as E naught oxidation plus E naught reduction.
Right.
So this would be, as we have seen just now, plus 0.14 plus 0.15, which we have just seen above. Hence the value of E naught from here is 0.29 volt. Now we know that E naught is equals to 0.0591 by n log Q, and the value of n is 2.
Yeah. 2 electrons are being exchanged.
Exchanged. So n equals to 2 clearly.
Yeah.
Now we just have to put these values in the formula.
Yeah.
That is in this formula, E naught equals to 0.0591 by n log K equilibrium.
Correct. So from there we can get the value of K equilibrium pretty easily.
So by putting the value of n equals to 2 here and the value of E as 0.29 here, and by simple calculation of these quantities, we can get the value of log of K equilibrium equal to 9.814.
Yeah, you can try this out yourself and see what value you get. Just confirm.
And just by taking anti-log, we can get the value of K equilibrium, and which would be 6.51 into 10 to the power 9.
Alright.
Hence, this is our final answer.
Alright. Yeah. So we'll move on to the next question. Alright, so in this question we have to calculate certain voltages and standard electrode potentials, and also calculate certain combinations of cells which would give us the required conditions that are mentioned in the question. So basically the question has two parts. In the first part we have to calculate the voltage of this given electrolytic reaction D2 minus D to B to B2 minus. And as you can see in this table in the figure, all the corresponding reactions are given along with their corresponding E0 values. So this is the first part of the question, and in the second part, like given the following half cell reactions, we have to find which combination of these two half cells would result in a cell with the largest potential, largest value of the potential. So Tushar, please take us through this question.
Okay. अब हम जब ये क्वेश्चन पढ़ चुके हैं तो हमारे दिमाग में अब तक स्ट्राइक हो गया होगा कि इसमें सिर्फ एक ही बेसिक फॉर्मूला यूज़ होगा, एंड दैट इज़ ई नॉट सेल इज इक्वल्स टू ई नॉट ऑक्सीडेशन प्लस ई नॉट रिडक्शन.
Yeah, we have used this formula several times before as well. So
okay. अब हमें फर्स्ट पार्ट में वोल्टेज निकालनी है इस गिवन सेल की. तो पहले देखते हैं सेल है क्या. इसमें D2 माइनस की ऑक्सीडेशन हो रही है D में,
राइट,
और B की रिडक्शन हो रही है B2 माइनस में जब हम इसमें 2 इलेक्ट्रॉन्स ऐड करेंगे.
राइट.
तो यहाँ से हम नेट रिएक्शन लिख सकते हैं. यहाँ पे हमें कुछ भी फैक्टर से मल्टीप्लाई नहीं करना किसी इक्वेशन को, क्योंकि नंबर ऑफ इलेक्ट्रॉन सेम है तो हम इसे कैंसिल कर सकते हैं. तो इट इज D2 माइनस प्लस B गिव्स D प्लस B2 माइनस.
राइट.
नाउ वी नीड टू कैलकुलेट द इलेक्ट्रोड पोटेंशियल फॉर दिस रिएक्शन एज पर द A part. Hence, for the first reaction, which is the oxidation of D, we can see from the given figure that for reduction of D, the value is plus 0.68.
Yeah.
Hence, when we reverse the reaction, it would be minus 0.68.
Yeah. Because this is oxidation in this case, yeah. So it will be minus 0.68. Yeah.
For reduction of B, the value is directly given as 1.25, which would be directly used here.
Yeah.
Hence, we can write E naught as E naught cell as E naught oxidation, which is minus 0.68.
Yeah.
We have just seen, plus 1.25. This gives us 0.57 volt.
Yeah.
Okay.
So this is the end of the first part of the question. Alright. So we'll move on to the second part, which deals with the combinations of half cells. Right? So please take us through that.
The second part wants the combination of the two half cell which would result the largest potential.
Right.
This is really one of the most interesting questions of electrochemistry, and which is quite often asked in competitive exams.
Correct.
So अब ये हम क्वेश्चन देखें तो हमें देखने में शायद मुश्किल लगे. 5 इक्वेशन दिए हैं, हर एक का कॉम्बिनेशन बनाएंगे तो काफ़ी सारे कॉम्बिनेशन हो जाएंगे. आपने किया ही होगा ये सब परमुटेशन कॉम्बिनेशंस में.
राइट.
लेकिन हम इसको काफ़ी सिंपल तरीके में करेंगे. हमें इस पूरे क्वेश्चन को कॉन्सेप्चुअली करेंगे और सिर्फ इन 5 इक्वेशंस को देखते देखते ही सॉल्व करने वाले हैं.
करेक्ट.
ओके. अब हमें बताइए ई सेल इज E cell oxidation plus E cell reduction. Hence, we can say that E naught cell would be maximum only when E naught oxidation plus E naught reduction would be maximum.
Correct.
Okay, तो हम E naught reduction की वैल्यू देखते हैं कि इन पांचों रिएक्शन में से किस में मैक्सिमम है.
Right.
तो अब हम इन सब रिएक्शंस में देख रहे हैं, तो हम कह सकते हैं कि जो सेकेंड रिएक्शन है दैट इज B, द रिडक्शन ऑफ B माइनस.
Right.
इसमें 1.25 which is maximum in all, which is maximum from all the E naught values.
Correct.
Hence, we can say that E naught reduction to be used here would be the B1. Okay, now E naught oxidation की maximum value चाहिए, तो हमें पता है रिडक्शन वैल्यूज दी हुई हैं, तो E naught oxidation maximum तभी होगा जब ये सबसे ज़्यादा नेगेटिव हो. तो हमें देखना है सबसे कम वैल्यू कौन सी है या फिर सबसे ज़्यादा नेगेटिव वैल्यू कौन सी है. तो हम जैसे इन पांचों इक्वेशंस को देखते हैं तो हम कह सकते हैं कि ये थर्ड इक्वेशन है और फर्स्ट इक्वेशन है, सिर्फ इन्हीं में नेगेटिव वैल्यूज हैं.
Yeah.
जिसमें से थर्ड में ज़्यादा नेगेटिव है, दैट इज -1.25.
Yeah. So when you reverse it, it will be the maximum oxidation
So
value.
it would be the maximum. Hence, the oxidation used would be -1.25, which would reverse and give us +1.25.
Correct.
Hence, E naught cell. This is the B part we're dealing with. So, hence E naught cell would be E naught oxidation plus E naught reduction.
Right.
Hence, we have just seen that E naught the maximum values E naught oxidation and E naught reduction,
Right.
and these were 1.25 plus 1.25.
Huh.
Hence, this would give us
2.5.
2.50 volt.
Right.
Hence, we have done this question conceptually, and this is the final answer. These questions are very easy, just
Yeah.
seems a bit difficult.
But I guess in the question we have to find out the reactions as well. So we should like write the combination of the two half cells, I guess. So we should just write down the reaction, I guess, for convenience.
Yeah.
Yeah.
We should write the reaction for convenience because sometimes the question may not be that simple. Hence, we should make a habit of writing the half cell reactions.
Yeah.
Here we have used this reaction C3 negative, which gives C negative plus 2 electrons, and B plus a electron gives us B plus 2 electrons B negative plus electron gives us B2 negative. These are the two half cell reactions, and from here we can easily write the full reaction. This should be written for the sake of convenience,
Yeah.
and this is helpful in many questions.
All right. So we are done with this question, and there's one small error in this figure. In case you haven't figured it out, this will be A plus E minus will be A minus, not B minus. So a small error, just a small error. So just keep that in mind. All right. So we'll move on to the next question. Alright, so in this question we'll use a number of very important concepts that we have learnt previously. We'll use the formula for calculating the E naught of the cell. We'll use the Gibbs free energy concept to check whether the cell reaction is spontaneous or not, and we'll also use the Nernst equation to find the required part of the third part of the question for finding the concentrations of the ions. So the question that we are given has three parts. In the first part we have to calculate the E naught of the cell for the following cell that is given here. The platinum Fe2 plus concentration of 0.1 molar and Fe3 plus concentration of 0.2 molar and Ag plus 1.0 molar to Ag. So given that the E naught for the Fe3 plus to Fe2 plus is 0.77 volt and the E naught for the Ag plus to Ag is 0.8 volt. In the second part we have to check whether this cell reaction is spontaneous or not, and in the third part we have to find the minimum Ag plus concentration possible before the electron starts flowing in the reverse direction. So Tushar, please take us through this question.
Okay, तो सबसे पहले इस क्वेश्चन में हम हाफ सेल रिएक्शन लिख लेंगे और उससे एक नेट रिएक्शन लिख लेंगे, उससे हमें थोड़ा आइडिया मिल जाएगा पूरे क्वेश्चन का और फिर सॉल्व करेंगे.
ऑलराइट.
ओके, सो एनोड कैथोड. एनोड पे Fe2+ which get converted to Fe3+. It is the oxidation at anode plus
Yeah.
electron, and at cathode it's Ag plus electron gives plus electron gives a solid Ag.
Right.
Okay, this is clearly from the given half cell. Now we can write the full reaction. This is Fe2+ plus Ag. We can directly cut the electron as there is one electron both sides. This gives Fe3+ plus Ag.
Right.
Okay, so this is our net reaction. In the first part, we need to calculate the value of E0 cell.
Right. Which we have done several times before. So
Yeah. So we'll directly apply the Nernst equation for this, and E cell is equals to E0 cell minus 0.0591 by n log Q. So for calculating the E0 value, we know the oxidation and reduction potentials here.
right.
Hence, this is for Fe3+, it would be minus 0.77, and
Yeah.
for the Ag it would be plus 0.8.
Yeah.
Hence, we can write this as 0.8 minus 0.77 minus 0.0591 by n. N is 1 here.
Yeah. One
Which is
electron is
directly
getting exchanged. Yeah.
Log of Q. Okay, for calculating the value of Q, we can see from the net reaction that the Q value is concentration of Fe3+ by concentration of Ag+ into concentration of Fe2+.
Yeah.
So these values are directly given here.
Correct. Yeah. They're already given in the question. So
we'll directly put these values to calculate the value of Q. This is 0.20 by 0.1 into 1. So this gives us 2.
2. Right. So this will be log 2.
So this would be log 2. Now E cell is equals to E0 cell. From here we can write this as, we will calculate and write this as 0.03 minus 0.0591 by 1 and log 2. The value of log 2 should be remembered as it may not be given in the question, and this
Yeah.
is 0.3.
All right.
Hence 0.03 minus 0.0591 into 0.3. Hence the value of E cell is 0.0122 V.
All right. You missed a 1 here, I think. Yeah. 0.05. 1. All right. So yeah, that concludes the first part of the question. So now we'll move on to the next part. Alright, so now we move on to the second part of question 11, in which we have to find out whether the cell reaction is spontaneous or not. Yeah, so Tushar will take us through this question.
Okay, for the second part, we know to check the spontaneity of the reaction, we need to calculate the value of delta G. Not exactly value, we need the sign of delta G more precisely.
Alright.
Okay,
Yeah.
so delta G is equals to minus NFE.
Yeah.
And we know the value of we know the value from the reaction that N is 1 here.
Yeah.
We know the value of F, which is positive, that's fine.
Yeah.
and we just calculate the value of E in the previous part, which is 0.0122,
Yeah,
and this is negative clearly.
clearly, yeah.
Hence the reaction is spontaneous.
Alright, since the Gibbs free energy is less than 0, this reaction is spontaneous at this
That
time.
is, it would be feasible.
Alright, so we move on to the third part where we have to find out the minimum Ag plus concentration possible before the electron starts flowing in the reverse direction. So Tushar, please take us through this.
Okay, so we need to find the Ag concentration, so we'll take the Ag concentration as xm molar.
Right.
Okay, so we'll take the help of Nernst equation here and write E equals to, that is E cell equals to E naught minus 0.0591 by n log q, and we calculated the value of q in the first part, and this was Fe3 plus by Fe2 plus into Ag plus. These are the concentrations.
Right.
Okay, so we need to find the minimum concentration of Ag before the electron flows in reverse direction. So just before the electron would be reverse their direction, that means the reaction would be in equilibrium just before that.
Right.
Hence at equilibrium we know that the value of E cell is 0,
Yeah.
and we'll use this only. We know the value of E naught cell as we calculated it in the previous part, previous part, which came out to be 0.03 volt.
Right. So this is the familiar Nernst equation that we know very well.
And we know the value of n is equals to 1.
Yeah.
Okay, so from this we can write 0 equals to 0.03 minus 0.0591 by 1 log of 0.2. This is given in the question,
Right.
by 0.1 into x, which we have assumed to be x.
Right.
Okay, so now we'll solve this equation. This is simple mathematics, like just simple calculation, not even mathematics. Just need to calculate this. Okay, now from this we can calculate the value of x.
Right.
We can write this as log of 2 minus log of x. This is a basic property of logarithms,
Yeah.
and this can be written we'll take this quantity here, so this would be 0.03 by 0.0591.
Correct.
From here we can directly calculate the value of log x, as we know the value of log 2, which is 0.3, and this is very important to be remembered.
Yeah.
It would be used in many questions. From here we can calculate the value of log x, and then we can take anti-log both sides to calculate the value of x.
Yeah.
So we can calculate the value of x from here, which will come to be 0.6215 molar.
Alright. So please do these calculations on your own and find the answer correspondingly and just check for it. So here you basically have to apply the basic concepts of the Nernst equation and remember the equilibrium conditions where E of the cell becomes 0. Alright, so we'll move on to the next question.